Okay, hello everyone. My name is Yeremia Eklesia Karno Misi, and today I will explain to you about the last problem on the assignment on the section C. It's about the real-world application of integration. So as we can see here, this is the R(x) and x, or the revenue function, or rate of the revenue change per product sold given by this one, the R(x) and x. The R action is the marginal revenue function, which describes the rate of changes in total revenue per unit increase in X. Okay. So we just go to A. Explain the economic meanings of integrating R, X, and X, and why the discount function is applied for X more than or equal to 5. So Rx and X is the marginal revenue function, and integrating the Rx and X gives us the total revenue increase, which means that it tells us how much total revenue increases as we go from one number of products sold to another. Okay, and why the discount function is applied for X more than or equal to 5? Because on the problem here, right here, we can see that for every additional product sold beyond by X equals to 5, so when you're selling the products beyond the X equals 5 or more, then the revenue per units decreases by 5% per unit. So this is answered. Okay, and then going up to B, set up the appropriate integrals to compute the total revenue increase. Okay, so the first one we got here is for sales between X equals to 3 and then X equals to 5. Okay, I already count this in the bottom here. This is the integration from 3 to 5, from X equals to 3 to X equals to 5. So we got this integration from X equals to 3 and then X equals to 5. That's the border for the integration. And then we can just put the revenue function here. Yeah, revenue function. This is the revenue function. R, X, and X. We integrate it as I explained on the A section. That will give us the total revenue increase. Okay, so for this one, as we can see here, we can just factorize them into this one. So X minus 2 times X plus 3. And we can just, using partial integration here, A over X minus 2 plus B over X plus 3. And we times A with X minus 2, and we times X plus 3, and then B also times the same one. So we will remove X minus 2 here with here. So we got A left with X plus 3. And then from the B, we remove the X plus 3 right here. And then B will only got X minus 2 here. So yeah, just apply that one here. Ax plus 3, bx minus 2, we calculate it, and then we got a equals to 4 and b equals to 1. We put that again. From this, we go back to this form, and then we just input the a and b. So right here, we put the a and b, then we integrate it, we calculate, and then we got this. Then 108, or maybe close to 4.787. And then for the integral of from x equals to 5 and x equals to 6, it was just as similar as before, but we have to times it with the discount factor, because as we can see here on the problems, for sales beyond x equals to 5 or more, beyond or more, then the revenue is adjusted by the discount factor. We have to times the revenue by the discount, by the discount factor, or dx. And what is the dx? The dx is this one. The dx is 1 minus 0.05 times x minus 5. So the calculation here, I don't really calculate it because it was so hard, and I think we cannot just calculate it by hands. Have to use programs, maybe a calculator. So I will just use the concept here. So as what I said, we got the revenue function here times by the discount function. So that's for B. And then for C, evaluate the integrals and interpret the result in terms of how market competition affect the company's revenue growth. Maybe for the sales beyond x equals to 5, it's quite a bit hard to just count it by hand, so let's just make the conclusion now. How market competition affects the company's revenue growth. So as we can see here, when x starts from 3 to 5, there will be no discount. So the revenue is maximum revenue, and if the x is beyond 5 or x is more than or equal to 5, then they have to apply the discount right here. And then what the discount effect? The discount effect is this one. The revenue per unit is decreased by 5% per unit. So when you give a discount to a unit, then the revenue will decrease by 5%. So the more product that we give discount to, then that will reduce the revenue to over 5%, 5%, 5%, and again and again and again. And then, yeah, that's it. That will decrease the revenue. Okay, I think that's all for me. I already explained about A, B, and C. I think that's clear enough. Okay, that's all for me. Thank you.